All right. Hello and welcome. I figured I'd give you the whole, class experience. So I just had to close my door because I'm going to record this. Okay. Whew. So if you're watching this video, you are about to complete the notes for day one in Unit 2E. And if you take a look at the title, it says completing the square to solve a quadratic equation. Okay, so notes day one. We're actually going to do most of the problems in day one, and then I'm going to leave us to a point where we can then do the last two examples in class. So this is going to be kind of like a little, warm up. But anyways, I want to start off by having you guys try the warm up. So 1A, B, C, and D. I'd like you to just pause the video, try those four warm up problems, and make sure that everything goes according to plan and you don't face too many troubles. So you're going to pause the video right now, try those four warm ups, and then unpause, and I will do those for you out. Okay? Pause. All right, how'd the warm up go? Hopefully, you guys did well. We're gonna do these kind of rapid fire because you can always go back and check your answers, rewind, and all that jazz. So, what we're gonna look at today here is how do you solve a quadratic equation, but it's not going to be the way exactly you think, right? Because usually we just factor, or like this one over here, right? You start off by dividing by 4. You get x squared equals 144 divided by 4. Okay, so 144, bada bing, that's 36. So, right, recognize that this problem is easy because you only have one quadratic term equal to a constant. And you take the square root of both of those and you get x equals plus or minus 6. Please make sure that in your answer you had plus or minus because we are solving. So 6 would work or negative 6 would work. Right? So that one was easy because it was just a single quadratic equal to a number. Now over here in part B, we have z minus 2 quantity squared. That's inside the parentheses. So the parentheses are basically just acting like a variable. We're going to take the square root and we're going to say z minus 2 equals, and at this stage of the game, we would probably say plus or minus 3, right? We're taking the square root of 9. So we kind of have to form two equations off to the side. And we're just going to have a positive 3 over here. Okay. And now we can add 2. I didn't have to do the plus or minus 3 part until the very end if I wanted to, I guess. But anywho, we have z equals 5, and we have z equals negative 1. So those would be your two solutions. And this one was easy because the binomial was already squared and alone. So we were able to just take a square root. Now over here, we have a coefficient outside. We're just going to divide by 2. And now we have that quadratic term isolated equal to 25. Take the square root of both sides. We get y minus 3 equals plus or minus 5. And then we add 3 to that. So we get y equals 3 plus or minus 5. And those two answers would be 3 plus 5 is y equals 8. And then we have 3 minus 5, so we get y equals negative 2. So a little bit more, right? A little bit more added on, and you get your two answers, right? But the parentheses were squared, so it's easy, right? Now over here, we can't quite do that, okay? Now I'm imagining that a lot of you saw this, and you figured out the fact that there were 3 terms, so maybe a little bit of factoring to do, right? But when we subtract that 1, we're going to change what the polynomial looks like a little bit, and that's okay. We can still solve it, but recognize that now we're looking for two numbers that multiply to 35 and add to 12. So we've changed the polynomial that we were originally given, which is totally fine because it had a 1 on the other side. We need to get things equal to 0 before we factor and solve. But I just wanted to point out that, it's a little bit different of a process. And I'm leaving this side open because I want to show you a different way that you might think is kind of cool. So have you thought of the numbers yet? I bet you have. How's that? 5 and 7? Right? Because 5 times 7 is 35. Add them up, you get 12. And of course, we get m equals -5 and m equals -7, and we are good to go. So you ready for the trick? It's kind of cool. So when you look at this, okay, that can be rewritten as what we call a perfect square trinomial. Now, you might be saying, what is a perfect square trinomial? Well, let's talk about that for a second. Okay, perfect square trinomial. I refer to them as psst. Psst. That's a joke. I hope you laughed or at least chuckled or smiled. But anyways, a perfect square trinomial is a quadratic that can be simplified in this term. Or simplified in this way, we'll say. Okay? X plus m squared. You can also have ax plus b squared. Right? You can have things in that form too. I just came up with m randomly. But the whole idea is that, right, a trinomial that can be written as a binomial squared. So slightly different, let's get a different color here. If I gave you x plus 5 and I said to square that, you would give me 5x plus the 5x, and then you give me plus 25. So we would say that x squared plus 10x plus 25, that right there is a perfect square trinomial. Because if I look in there, right, I look inside, there's some special stuff going on. And I know that there's not like a super ton of space in your packet for this, but I'd say just find like a little spot for this. You look at that 10x, and you think back and you say, all right, that 5 right there, right? How do we get from this 10 back to the 5? Well, you're going to take 10 divided by 2, and you get 5. And then you take that 5 and you square it, and that gives you the constant term. Right? So please recognize that we're using a coefficient of 1 right now, and that's all you're going to do in this video is a coefficient of 1. We'll talk about the coefficient other than 1 in class. But right, I want to bring this back to the idea of ax squared plus bx plus c. Okay? And what we want to really pick up on here, we'll go one more color here, is that the b term right here, right, that is double whatever this original number is, the 5. So you want to start off by taking the b term and dividing it by 2, and that gives you the constant. So if we go back to this idea right here, right, that b over 2 is the m in that formula. And furthermore, we know that b over 2 squared is going to always equal the constant of our perfect square trinomial. So I'm going to show you how to make sense of that information and use it appropriately, but I wanted to at least get those wheels turning that this 10x is very much related to creating that constant, okay? It goes back to this, right? 5 and the 5, and then of course you see this 25. So you can kind of think of this as like part of that b over 2, right? That is always going to be there, and then this is always going to be b over 2 squared. Right? So don't feel like you got to rewind this part of the video and go back and have like a perfect 100% understanding of this, but at least let this kind of hit you so you understand where some of these numbers are coming from. Okay, so that's a perfect square trinomial. Perfect square trinomial. So now that we have that in our heads, let's talk about D again. Okay, so I look over here at m squared plus 12m plus 36, and you might be recognizing already that that 12 divided by 2 is 6, and then the 6 squared does turn into the constant term. So what I'm going to do here is I'm just going to write this as m plus 6 squared equals 1. Right? And off to the side, if you want to FOIL out m plus 6 times m plus 6, then you'll see that it is equal to this quadratic. Right? So here's the even better part about knowing about these perfect square trinomials. Right? Is that now I can take the square root of both sides. I get m plus 6 equals plus or minus 1. Subtract the 6 away. We get m equals negative 6 plus or minus 1. So negative 6 plus 1 would be m equals negative 5. And then negative 6 minus 1 is m equals negative 7. I mean, that's kind of cool, right? Like, that is kind of cool. Maybe, teeny bit. Okay, so we're going to practice that today. We're going to make sure that you know how to turn one into the other. So we'll start slow and then we'll work our way up. Okay, so what I want you to do right now is look at that quadratic, x squared minus 10x plus 15, and just try and think like, all right, so if the middle part is negative 10, what does that constant have to be? I want you to pause the video. Try and think of what does this number have to be so that we can write this in this term. And actually, I'm sorry, it should be x minus 10 for this one, is the negative 10. But pause it and try and come up with like, what perfect square trinomial are you so close to here? Pause it. I hope you got it. You could always rewind the video too. Remember we said it's the b term divided by 2. So what we're going to do is we're going to take that negative 10, b over 2 equals negative 10 over 2, and that equals negative 5. So what this is really kind of saying here is that on the second line of work, we want this to say x minus 5 squared equals something. And if you FOIL that out, you know that it's x squared minus 10x plus 25. So if we squared this negative 5, that's where we get the 25 from. So now you must be wondering, okay, so how can I just magically turn this into a perfect square trinomial? And the answer is going to feel a little bit weird, right? That we can actually just subtract that. Okay, I'm going to bring this down a little bit more. So we can actually subtract 15 away from both sides because we're allowed to do that. Right? Like we can subtract something from both sides and still have the equation be equal. So that's really what's happening here. Okay, so I subtracted 15 from both sides, and now I'm going to write this as x squared minus 10x plus a blank equals a negative 15 plus a blank. And I actually do encourage you to write those blanks in, because if you realize the negative 5 squared is 25, now we're just going to add 25 to both sides. So that is going to allow us to turn this into x minus 5 quantity squared. And then we have a little bit of a work to do here. We got to combine these two, and we make it 10. Right? Negative 15 plus 25 is 10. And from here, we can solve. We're going to say x minus 5 equals plus or minus root 10. And then we're going to add 5 to both sides. And x equals 5 plus or minus square root of 10. Voila. Right, there it is. Now, you might be thinking, that's the answer to the quadratic? Right? All the other ones on top, we got whole numbers, integers. Right? What kind of answers to quadratics end up looking like that? You think? Right? Think back. Here we have something plus or minus the square root of x equals negative b plus or minus the square root b squared minus 4ac. That's it. That's it. We got answers like that with the quadratic formula before. Let's try it. Hold on. Let's see. We got to make sure we're all on board with this, okay? So, where is it? Where is it? X squared minus 10x plus 15. X squared minus 10x plus 15. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, x equals negative b. That's a plus, right? Negative 10 plus or minus the square root of b squared minus 4ac over 2a. Yeah, that looks good to me. All right, so let's try it. We've got x equals 10 plus or minus the square root of 100 minus, now, 4 times 15 gives us 60. And again, this is all over 2. So we go forth here, and we say 10 plus or minus the square root of 40. That's all over 2. So let's see, is this looking like what we were doing before? 5 plus or minus the square root of 10. Okay, that was the answer we're looking for. And we know that this breaks into 4 and 10, so that I could say 2 root 10, because this is really 4 times 10 here. So the 4 comes out as a 2. So we're going to say x equals 10 plus or minus the square root. Oh, just kidding. We simplified that square root. So we're going to do 2 square roots of 10 divided by 2. So that's 10 over 2 plus or minus 2 root 10 over 2. And what do you know? 5 plus or minus root 10. Again, pretty cool. Just saying. Hashtag just saying. All right. So, do you believe me now? Like, that is the answer. I promise. I promise. So, let's try another one. We're only going to do 2 more examples, but this talk was essential to your understanding. I do believe that. So, here we go. So, this time, the given quadratic did not give us a number, and that's okay. That's actually really good. That helps us, because here's what we're going to do. We're going to set this up as c squared plus 4c plus a blank, because we got to make that correct number. And we set it equal to 2, because that's on the other side. But remember, we're going to just add something extra in, and whatever we do to one side, we have to do to the other. So off to the side here, I'm going to take b over 2. And that is 4 over 2, which is 2. So I know that this is the part of my binomial. I need a c plus 2 squared. And I also know that the constant should be 2 squared, which is 4. So I'm going to put a 4 in here and a 4 in here. And now we're going to make c plus 2 quantity squared. And that actually does give you, right, c plus 2 times c plus 2 Brings you back. Okay, we're good. Yeah, brings you back to c squared plus 4 plus c. And now we're ready to go. Take the square root. C plus 2 equals plus or minus the square root of 6. And the final answer is negative 2 plus or minus the square root of 6. Good stuff. Any questions? Of course, I'll have to wait until I see you next. I could pretend like we're in class. Any questions? Any questions to the people at home? Okay, no questions. All right. So here's the last two. We're going to do 4a and 4b in class, but I'm going to start off here with d squared plus 5d. We have a blank, and then we're going to have 5 plus another blank. He's going to make us do the fraction ones. How annoying is this? And we got to do the b term, which is 5. We got to divide it by 2. And in the past, we got a 10 divided by 2, that was 5. Right? 4 divided by 2 was a 2. Life was good. Life was simple then. But now we have to take 5 halves. Right? And we need to keep the vision alive that d plus 5 halves squared, that's our vision. That's what we want to happen here. So in order to make that happen, we're going to have to square and get 25 over 4. And I'm going to put that in right here, 25 over 4 and 25 over 4. So realize that 5 halves plus 5 halves would give you 10 halves, which is 5. So I know that it might not be perfectly comfortable at the moment to write that that binomial squared in blue and really like feel like you know that's true, right? But then if you need to do that on the side and FOIL that out, do it so you convince yourself, okay? But we've maintained equality because we added both of these in. And I'm going to make 5 have a denominator of 4. So we would need to multiply that by 4 over 4. So this is really 20 over 4 plus 25 over 4. So on the next rewrite, I'll combine those two fractions that now have a common denominator. There you go, okay. And we have officially written it as binomial squared equal to a number. And at this moment, we can take the square root of both sides, d plus 5 halves, that is equal to, now, square root of 9 times 5 over square root of 4. So if you get the square root of 9, that's popping out as 3 root 5 over 2. So we've got plus or minus 3 root 5 over 2. Just to recap that part, right? Because usually what's been happening at that stage is that we just get a number like 10. We got a number like 6, okay? On this one, it's feeling kind of strange because that square root simplified, but if it hadn't simplified any other problems, we would have written it differently. So now we've got it in its true form without the unnecessary root 45. And I'm going to subtract 5 halves away from both sides. And your final answer should look like this, okay? D equals negative 5 halves plus or minus 3 root 5 all over 2. And if you're feeling fancy, you can write that as one big fraction like this. Right? D equals negative 5 plus or minus 3 square roots of 5 all over 2. So if you needed to, manipulate this solution some more, I would go with that rewrite. But if you're just looking for an answer, that one is A-okay. All right. So I think at this stage, you should probably pause the video, try letter B on your own, and then maybe, fast forward to the spot where you get stuck, or just go to the end and verify that you get this right. But for the purposes of the video, let's continue, right? So I'm moving the constant away, right? So number one, let's move the constant. Number two, you're going to add your b over 2 squared to both sides. And number three, we want to rewrite the perfect square trinomial, the ps, as x plus m squared. So let's get that far at least. We have e squared plus e plus a blank equals 3 plus that blank. So I guess a little mini halfway in between step is add blank both sides. And I'll switch colors over now. Okay, so we have our b term, and our b term over 2 is really just 1 over 2. So we're looking to make this into e plus 1/2 squared. Now over here in step 2, it says add b over 2 squared. So that's now 1/2 squared equals 1/4. So that's 1 times 1, 2 times 2 on the bottom. So we're going to add that 1/4 in here because we need to make sure that our equation looks like this looks when it's expanded. So I added 1/4 to both sides. And over here, of course, we've got 1/4. And I think we have to go one more, right? So 3 over 1. Let's see, let's make that into fourths. 12 over 4. So this is really e plus 1/2 squared equals, that 3 we just found out is 12 fourths. So 12 fourths plus 1 more fourth is 13 fourths. Oh yeah, we're going to bring it home now. This isn't too tough from here. We're going to take the square root. We get e plus 1/2 equal to plus or minus root 13 over 2. So I took the square root of 4 there. So subtracting 1/2 away, we get e equals -1 plus or minus root 13 all over 2. And if you're wondering where all that came from, right, this is the -1 right there. The fact that both of these are halves is why I chose to write a single denominator of a half, and then root 13 is right here. So I would say the final answer for that one is E equals -1 plus or minus root 13 all divided by 2. So as always, you can rewind this video if you need. I hope this wasn't too long. I'm thinking it was probably close to like 15 minutes, but anyways, I will upload this. I'll make it an assignment, and I will see you on Monday or Tuesday, depending on when. Actually, I might see someone. We'll figure it out. I'll see you when I see you. Have a good day.